let's go ahead and look at these problems that will be similar to things that you will see on your test for sections 3.1 and 3.2. So the first thing we talked about was using the formal definition to find a derivative. And if you recall f prime or dy dx of the derivative, the formal definition is the limit as h goes to 0 of f of x plus h minus f of x over h. So the f of x plus h, when we are plugging in x plus h for x, function just normal function over h. So if I'm looking for the derivative of 3x squared minus 6, there are two places to plug in x. So when I do my f of x plus h, I'll put it in two places. So y prime is going to equal the limit as h goes to 0 of 3 times x plus h squared minus 6x plus h. So there's my first part. That's my function at x plus h. Minus the function, so minus the entire function in its totality, all over h. So hopefully lots of things cancel, and it will. So I can FOIL out the x plus h squared. If you recall, we said that's x squared plus 2xh plus h squared. And you could certainly go ahead and FOIL that out, but if you remember that expansion, that's helpful. I'll distribute the negative 6, and then I'll distribute the negative sign on the last part through the original function all over h. So once I FOIL the x plus h, I also have that 3 I have to take into consideration. So I'll take the 3 through that, so 3x squared plus 6xh plus 3h squared minus 6h minus 6, or 6x minus 6h minus 3x squared plus 6x all over h. Now in general, you know you did this right because I'd like to have everything that doesn't have an h cancel out, and it does. 3x squareds and the 6x, everything else has an h. So the benefit of that is because, I want to get rid of that h on the bottom because I don't want the 0 over 0 limit, so I'm going to try to get rid of that h. So if I factor h out, I get 6x plus 3h minus 6 all over h, which will then cancel that h. So now I have no denominator, so there are no problems. I'll just go ahead and put 0 in for this h, and so I will get my derivative, which is 6x minus 6. The nice thing now that we didn't have when we did these the first time is you can check it with our shortcut rules. Bring the 2 down, multiply it to the 3, 1 less power, and then negative 6x just drops the x, so you get minus 6. So this checks out with the shortcut rule as well. Now the second problem says, again, we want to use the formal definition to find the derivative, and then I want to find the tangent line. So we're not only finding the derivative, but then we're going to use it to find our tangent line. So again, I'm going to go ahead and find the derivative. So I'm going to find f prime of x. So it's going to be the limit as h goes to 0. And this one, believe it or not, we have to do this way because we do not have a way to do the square root of more than one thing like we have here. So I replace the x with x plus h minus the function all over h. Now, these all had a trick, and if you remember the trick for a radical, it's we're multiplying by the conjugate. So we're going to multiply by x plus h plus 1 plus radical x plus 1, and we're going to do that on the top and the bottom. Now, on the top, we'll go ahead and FOIL, and I could just do these two because the inner and outer cancel out. They always do. So this is going to give me the limit as h goes to 0 of x plus h plus 1 minus, don't forget it's going to be minus x plus 1 because when you do the two radicals with the minus inside, it is going to carry through. And then we'll have the x on the bottom, or the h on the bottom, pardon me, x plus h plus 1 plus radical x plus 1. Now if I do my distribution and everything now, let's see, we'll get x plus h plus 1 minus x minus 1, just taking care of things on the top, all over h, radical x plus h plus 1 plus radical x plus 1. Now you'll know you do the square root problems correctly, because if I've done it correctly, then everything except for the h, or sometimes a number times h, will go away, and it certainly does. So everything goes away there except for the h, and so now I can cancel that h with the 1 on the bottom, and I get just 1. So now I only have one h left, and that's the h inside the square root, which is okay, because if I put a 0 in for there, I don't get 0 for the whole bottom. I just get 1 over radical x plus 1 plus radical x plus 1, which is going to lead me to my final derivative, 1 over 2 square root x plus 1. So that is the derivative. Now, unfortunately, this is not the only problem we have here. We actually have to find the equation of the tangent line. Okay? So let's go ahead and jump up here. And to do the tangent line, we have to find the slope and the y-intercept. The slope is very simple, because the slope is just going to be the derivative at 8. So I'm just going to plug 8 into my derivative. So 1 over 2 radical 9 is going to be 1/6. So that's my slope, because the square root of 9 is 3, and 3 times 2 is 6. So now I have to find my y-intercept, and to do that, I need my x and my y from my original. So I know the x is 8, but I didn't know the y. So I'm going to plug that into the original, and I'll get the square root of 8 plus 1, which is the square root of 9, which is just 3. Now that's really important, because to get my b, I need to do my y equals mx plus b. So y being 3, m being 1/6, and x being 8, I can solve for b. So let's see, this is 3. 8 times 6 is 8/6, or 4/3, plus b. And then I'll just subtract 4/3 from both sides. So 3 is 9/3. 9/3 minus 4/3 is 5/3. So I have my intercept, I have my slope, but I still have to write my final tangent line equation. Y equals 1/6 x plus 5/3. And remember, if you graph this tangent line and our original function at the point x equal 8, the line should look tangent to the equation. All right, this last question is all just using our derivative rules. So remember our derivative rules, we have the power rule, where we have the derivative of x to the n. So if you recall, we have x to the n. Its derivative is the n, x to the n minus 1. And then the derivative of a constant, if you just have a constant by itself, the derivative is 0. So if we look at some of these, some you have to rewrite, some you don't. Like for a, there's really not much to do. You can just pretty much take the derivative. Take the 3 down. 3 times 5 is 15. X to the second, because 1 less power is 2. Plus 6, because again, you take the 3 down here. 3 times 2 is 6. X to the first. And then you have negative 2/7 x, which just becomes negative 2/7, because the x just becomes x to the 0. And then the 2, the derivative of 2 just goes away. So that is my derivative. Now for b and c, these both are going to require a little bit of work before we take the derivative. So we're going to have to manipulate it just a little bit. Okay, so on this first one, we can rewrite this. So this will be y equals x. So it's root 5 of third power of x. That's 3/5. Minus 3x to the 1/2, because again, square root just becomes 1/2, plus 8x to the minus 4. Now, I've done no calculus yet. All I've done is rewrote these to be in a form where I have x to some power. So now when I do the derivative, bring down the power, 3/5 x. 3/5 minus 1, or 3/5 minus 5/5 is negative 2/5. Minus, take the half times the 3, you get 3/2, or 1.5. X to the minus half. And then bring the negative 4 down, we'll get negative 32, x to the minus 5th. Now, one thing we need to do is we want to make sure that we get rid of any negative exponents, and these all have negative exponents. So anything with a negative exponent will just drop to the bottom. So this is 3 over x to the 2/5 minus 3 over 2x to the halves. Notice I'm not dropping the number down because the number is separate from the variable and its power. Negative 32 over x to the 5th. All right, if we look at C, C has two things multiplied. Well, as of this moment, we have no rules on how to find the derivative of two things multiplied. So before we take any derivatives, we're just going to have to multiply those two things together. So we'll just FOIL and do our, see what we end up with. So 2x cubed minus 6x squared plus 3x minus 9x. So before doing any calculus, I FOIL this to be 2x cubed minus 3x squared minus 9x. Now from here, I could take the derivative. There's nothing tricky about this. It's just power rule. It's kind of like A. So bring down the 3, 6x squared minus 6x minus 9. And again, you could find the slope on a quiz. You could find the tangent line, whatever it needs at that point. All right, our last one is our transcendental functions. And we just have to kind of know what the derivative of these big three are. So remember, the derivative of sine is cosine, just straight cosine. So the sine just becomes cosine in the derivative. Anything with an e to the x, or e to the t, or e to the anything simply just stays the same. E to the x has its own derivative. And the derivative of cosine is negative sine. So the negative 7 out front will become positive 7 sine x because it's negative 7 times negative sine, which becomes your positive sine x. So for right now, the trig ones are pretty straightforward because we only have the three. We have the cosine, we have the sine, and we have the e to the x. They will get markedly hard in the future. So hopefully this is helpful. Hoping you prepare for our first quiz of this chapter.